Hello, everyone, and welcome to Pre-Calculus Lecture 17. Today we're talking about synthetic division. And the objective of synthetic division is to divide a polynomial p of x by a first-degree polynomial of the form x minus c. The polynomial p of x, the thing that's being divided, is called the dividend, and the polynomial x minus c, the thing that we're dividing p of x by, is called the divisor. And this process of synthetic division is best illustrated by example. And so we're going to do an example and write down the steps as we do it. And we'll do it that way once or twice, and then after that we'll do a few examples where we don't write down any of the steps. We'll just perform the process. The process, unless we really want to investigate the mechanics of polynomial division, isn't going to make any sense. It's just a process that we want to learn by rote memory, and we don't really care why it works. And so we're not going to explain why it works. We're just going to do the process and learn how to do the process. Here's our first example. The polynomial p of x is 2x cubed minus 3x squared minus 2. And we're dividing that polynomial by the first degree polynomial x minus 3. And this is our x minus c right here. Now let's do this, writing down all of the steps. First thing, write the dividend, that is p of x, in descending powers. And when we do this, we're going to include terms of all degree. And I say that because here we don't have a term of first degree. There's no x term here written. But when we write the dividend, p of x in descending powers, we're going to have a term of first degree. So here's how we write it. 2x cubed minus 3x squared. We need an x term here, so what we do is we write that as 0 times x. There's our first degree term. And then minus 0. Beautiful. We just wrote the dividend, p of x, in descending powers, and we included the terms of each degree, even this term of degree 1, which didn't appear, it wasn't written explicitly in the polynomial, but it is here. The term of first degree is 0 times x. And we need to have this written down to do synthetic division. The second thing that we do, copy the coefficients. 2, negative 3, 0, negative 2. 2, negative 3, 0, negative 2. There. So easy, even I can do it. The next step, place the long division symbol around these coefficients. Okay, I think I can do that. 2, -3, 0, -2. Beautiful. There's my long division symbol. And let's see, I'll do one more step. Fourth step, place the constant term of the divisor. Next to the division symbol. Here's our long division symbol with the coefficients inside. And we're going to take the constant term of the divisor. Here's the divisor. And we take that constant term and place it next to the division symbol. The constant term and we're not going to write the minus sign that appears in front of it. Our divisor is of the form x minus c. We're going to write whatever c is, not considering the minus sign. Now I'll pause so I can clear the board and write some more. The next thing we do is create 3 rows, so to speak. This will be row 1, a blank row underneath, and then below this horizontal line is row 3. We just created 3 rows. Step 6. Bring the leftmost coefficient down 2 rows. So here's what we got. Here's row 1, row 2, row 3. Step 6 says bring the leftmost coefficient, that's this guy, down 2 rows. And 2 rows should be 2 words. Bring the leftmost coefficient down 2 rows. So we copy it down here. And that leads us to step 7. Multiply by the constant term. Of the divisor. And we write the result one column over, 1 row Okay. We multiply this by the constant term of the divisor, 3 times 2, and we write this 1 column to the left, 1 row up. And our next step, add rows 1 and 2. Place the result in row 3. And notice that we are adding rows 1 and 2. When we do regular division, don't we subtract this thing from this thing? Well, when we're doing synthetic division, we add these 2 things. So just be aware of that change. And let's see what we got. Here's row 1, row 2, row 3. Is that going to fit on my screen? Son of a gun, it is. Okay. Whoops. Let me go back to this step. I just shot myself in the leg, and I'd like a moment to be able to remove the bullet if I can. Step 6 says, no, step 7 says, multiply this constant, this number, by the constant term of the divisor. So we take 2, multiply it by 3. That should give us 6 here, forgive me. And we take this result, 3 times 2, and write it 1 column over and 1 row up. This is the result of the constant term of the divisor times this number, 3 times 2. Oh my goodness, I apologize for that. Step 8, add row 1 and row 2. 2 plus nothing is 2. Negative 3 plus 6 is positive 3. Okay. And now we're on to step 9. I just wrote down step 8 again so that we'd have some sense of continuity from the previous board to this board. Step 9 is just repeat the previous 2 steps. Step 7 tells us to take this number and multiply it by the constant of the divisor, the constant term of the divisor. So we're going to take this number and multiply it by 3, and we're going to write it 1 column over and 1 row up. So that should give us 9 here. Step 8 says, add rows 1 and 2. 2 plus nothing is 2. Negative 3 plus 6 is 3. 0 plus 9 is 9. And then what do we do now? We repeat step 7 and 8 again. We take this number and multiply it by the constant term of the divisor. So we have 3 times 9, and that gives us 27. 3 times 9 is 27. We write this one column over and one row up. That's 27. And we add rows 1 and 2. 2 plus nothing is 2. Negative 3 plus 6 is 3. 0 plus 9 is 9. Negative 2 plus 27 is 25. Essentially, we've completed the synthetic division process. What we have to do now is know how to interpret the results. The rightmost term is the remainder. And let's see, every other term the other terms are the coefficients of a polynomial of degree 1 less than P of x, the dividend. Now, P of x, if I remember right, was a polynomial of degree 3. So these coefficients are going to be coefficients of a polynomial of degree 2. Two x squared plus 3x plus 9, remainder 25. So let me summarize this. I guess I have enough room there. If we divide the polynomial P of x by x minus 3, we're going to get 2x squared plus 3x plus 9, remainder 25. Let's try another one. Let's try another one. X to the 4th plus 2x squared minus 3x plus 5 divided by x minus 2. Okay. Step 1. Write the dividend in descending powers. X 4th up And remember, when we do this, we have to include terms of each degree. We don't have a degree 3 term here, but we got to write one down. So we'll have 0x cubed plus 2x squared minus 3x plus 5. So that's our first step. Write the dividend in descending powers. We did that. The next thing, copy the coefficients. See, coefficient here is 1, 1x to the 4th. 0, 2x squared minus 3x plus 5. There, we copied the coefficients. Step 3, place a long division symbol around these coefficients. Step 4, take the constant term of the divisor, the thing that's being subtracted here. Take the constant term of the divisor and put it next to the long division sign. Step 5, create 3 rows. So we have row 1, row 2, row 3, and between row 2 and row 3 we have a horizontal bar. Step 6, bring the leftmost coefficient down and copy it in row 3. 1, 0, 2, negative 3, 5. So we bring the leftmost coefficient down and copy it. And then step 7, we multiply this constant term by the constant of the divisor and write it 1 column over and 1 row up. So we multiply this thing by the constant term of the divisor, 2 times 1. We go over 1 column to the right and up 1 row. And we write it down. And then step 8, we add rows 1 and 2. And step 9, repeat the previous 2 steps. So now we take this thing, multiply it by the constant term of the divisor, 2 times 2, go over 1 column and up 1 row. 2 times 2 is 4. and we add. 1 plus nothing is 1, 0 plus 2 is 2, 2 plus 4 is 6. And then we do it again. Take this most recent term, multiply it by the divisor of the constant term. 2 times 6 is 12. Go over one column to the right, up one row. And we add the rows, 1 and 2. 1 plus nothing is 1, 0 plus 2 is 2, 2 plus 4 is 6, negative 3 plus 12 is 9. Okay. Do it one more time. Take the most recent term, multiply it by the constant term of the divisor. 2 times 9 is 18. And write it up here. One column over, one row up. And we add again. 5 plus 18 is 23. And we've finished the synthetic division process. We just have to analyze what it is that we have now. The rightmost term is the remainder. All of these other terms are the coefficients of a polynomial of degree 1 less than the original polynomial. The original polynomial was degree 4, so these are the coefficients of a polynomial of degree 3, which means we have 1 times x cubed. And we have 2 times x squared and so forth. Oh, I shouldn't have erased the original problem. Oh well. I can write it again. Let's see, was that the original problem? X to the 4th plus 2x minus 3x plus 5 divided by x minus 2. It sure is. And that's equal to 1x cubed, or just x cubed, plus 2x squared plus 6x plus 9 with a remainder of 23. Okay, the next example, we're just going to acknowledge all the steps that we take, but we're not going to write down nearly as much detail. We're going to omit a lot of the details now and just go through the mechanics. We've done this twice. We're going to go through it a few more times and just get the process down without having to write down the steps. I have thrown in a little bit of a wrinkle or a twist here. Remember, in all of our examples before, the divisor has been of the form x minus something. Our divisor doesn't have that form. Well, let's see. Can I rewrite it so that it does? Maybe I can. 5x cubed minus 2x plus 7 divided by, and I need to write this as x minus something. So how about x minus a negative 4? That's going to be our c. Negative 4 is going to be our c. So what do we do now? We write the terms of our dividend in descending order, and we include the terms of each degree. So 5x cubed plus, we don't have a squared term here, we'll write that, 0x squared minus 2x plus 7, that's good. And we're dividing by x minus a minus 4. We take the coefficients. I said we take the coefficients. There we go. 5, 0, negative 2. And what do we put here? The constant term of our divisor. It's whatever is being subtracted from x. So here, that constant term is going to be negative 4. There we go. And we create our 3 rows. Bring down the leftmost coefficient, copy it in the 3rd row. We multiply this by the constant term of the divisor. Negative 4 times 5 is negative 20. So we move that over 1 column and up 1 row. And then we add the rows. 0 plus negative 20 is negative 20. We take this expression and multiply it by the constant term of the divisor. Negative 4 times negative 20 is positive 80. We go over 1 column and up 1 row and write it, positive 80. We add the rows. Negative 2 plus 80 is 78. And we take this figure, multiply it by the constant term of the divisor, negative 4. Negative 4 times 78, holy moly. Let's see, negative 4 times 80 is negative 320. So let's see, this should be negative 312, I believe. Oh, I sure hope I'm right. And we add these two guys. 7 plus negative 312 is negative 305. Negative 305 is our remainder. The other coefficients are coefficients of a polynomial of degree 1 less than the original. The original is degree 3, so these are the coefficients of a polynomial of degree 2. 5x squared minus 20x plus 78, and then we have remainder negative 305. Let's do one or two more. Okay. This exercise asks us to use synthetic division to determine, and you know, in the old days, they used to spell determine with an E on the end. Use synthetic division to determine whether or not x minus 5 is a factor of this polynomial. Well, what does synthetic division have to do with x minus 5 being a factor of p of x? Here's the connection. If x minus 5 is a factor of p of x, then p of x divided by x minus 5 will have a remainder of 0. And that works just with regular numbers too. Is 5 a factor of 20? Let's see, 20 divided by 5 is 4 with a remainder of 0. Yeah, 5 is a factor of 20. Is 5 a factor of 32? 32 divided by 5 is 6, remainder 2. Okay, there's a remainder there, or a remainder of 2? Nope, 5 is not a factor of 32. The same thing works with polynomials. Is x minus 5 a factor of p of x? If it is, then p of x divided by x minus 5 will have a remainder of 0. So, what they're really doing is telling us, divide p of x by x minus 5 and see if the remainder is 0. So, let's take p of x. We write down the terms in descending order, and we include terms of every degree. I think here we have that. Degree 3, degree 2, degree 1, degree 0. Yeah. We don't have to insert any terms here. And then we write down the coefficients. And put them inside the long division sign. That we look at our divisor, and whatever it is that's being subtracted from x, in this case we're subtracting 5. So whatever it is that's being subtracted from x, that's what we write down here. And we have 3 rows. We take the leftmost coefficient and copy it in row 3. And then we take this number, multiply it by the constant term of the divisor, and write the result 1 column over, 1 row up. 5 times 2 is 10. We add rows 1 and 2. Negative 13 plus 10 is negative 3. We take this new result, and what do? Multiply it by the constant term of our divisor 5. Negative 5 times negative 3 is negative 15. We write that 1 column over and 1 row up. Negative 15. And we add rows 1 and 2. And that 19 plus negative 15 is 4. We take this result, multiply it by the constant term of our divisor, 5. 5 times 4 gives us 20. We add rows 1 and 2, we get 0. Aha! 0 is our remainder. So P of x divided by x minus 5 has remainder equal to 0. X minus 5 is a factor of P of x, where P of x is equal to 2x cubed minus 13x squared plus 19x minus 20. So we took this polynomial, divided it by x minus 5, and had a remainder of 0. That means that x minus 5 is a factor of that polynomial. Let's revisit the same exercise that we just did. Could we have done this without synthetic division? And the answer is yes. X minus 5 is going to be a factor of P of x exactly when P evaluated at 5. See, x minus 5, take the number that's being subtracted from x. X minus 5 is a factor of P of x exactly when P evaluated at 5 equals 0. So we could have just plugged 5 in here. And if we got 0, we'd say, yeah, x minus 5 is a factor. So we plug in 5 and we get 2 times 5 cubed minus 13 times 5 squared plus 19 times 5 minus 20. 5 cubed is 125, so 2 times that is 250. 5 squared is 25. So I think that's 325. Yep. And 19 times 5 is 95. Well, let's add up our negatives and our positives. Our negatives, negative 325 plus negative 20, that's negative 345. And our positives, $250 plus 95 is 345. So essentially we got 345 minus 345 is 0. Okay. P of 5 equals 0. Therefore, x minus this number we plug 5 into P of x and get 0, so x minus that number, x minus 5, is a factor of P of x. So there was another way of doing that exercise without using synthetic division. But it's nice to know both ways. And sometimes it might not be obvious what the factor is. Sometimes synthetic division may be the way to go in an exercise like this. I just couldn't resist doing one more exercise, and here it is. Use synthetic division to determine whether x plus 3 is a factor of p of x, where p of x is the polynomial negative 4x cubed plus 5x squared plus 8. And we recognize that if x plus 3 is a factor of p of x, then p of x divided by x plus 3 has a remainder of 0. And we also realize that if we're going to do synthetic division, that we have to rewrite our divisor so that it has the form x minus something. So we're going to write the divisor as x minus a negative 3. Let the games begin. We write the dividend in descending powers, and we make sure that we include all powers of x. Here we have third degree, second degree. We don't have first degree. We don't have a term something times x. We're going to have to include that. So we write p of x this way. Negative 4x cubed plus 5x squared plus 0x plus 8. And from this polynomial, we write down the coefficients. We put them inside our long division symbol. And we take the constant term of the divisor, the thing that's being subtracted from x, and we write that down next to the long division symbol, negative 3. And we create row 1, row 2, row 3. And what do we do next? Don't we bring down the leftmost term or coefficient, the leftmost coefficient, and write it in row 3. And then we multiply the constant term of our divisor times this thing, negative 3 times negative 4. We bring it over one column and up one row. That gives us 12. And we add rows 1 and 2. Okay, we take our newest figure, 17, multiply it by the constant term of the divisor. Negative 3 times 17 is negative 51. So we write that one column over and one row up. And we add rows 1 and 2. We take our latest figure, negative 51, multiply it by the constant term of the divisor. Negative 3 times negative 51 is positive 153. We write that one column over and one row up. And we add, and we get 161. That's our remainder. Well, our remainder is not equal to 0. And what that means is that x plus 3 is not a factor of p of x, where p of x equals negative 4x cubed plus 5x squared plus 8. And we are done.